Tesla's fleet GNSS correction turns isolated cars into a shared reference network that pins urban positioning back to the road for FSD. This is Tesla Shorts Time, episode 558. A single vehicle in a glass canyon receives distorted satellite signals that drift its calculated position toward curbs or buildings. One car matches visible landmarks to a stored visual map and sends both its map pose and raw satellite measurements to a server. Nearby vehicles receive the paired data, combine it with their own readings, and use real-time kinematic processing to calculate relative position vectors that correct the drift. The updated pose returns through the server to surrounding cars, giving the fleet a stronger shared reference. This approach moves FSD positioning from isolated receivers to a moving network that improves accuracy at city scale without requiring direct line of sight between vehicles. The method lowers per-car hardware requirements while improving worst-case urban accuracy that regulators will scrutinize. While the positioning network strengthens the software stack, a separate regulatory probe is now testing the hardware side of the existing fleet. Regulators opened an investigation covering 1.2 million Tesla vehicles for potential suspension defects. The probe adds to existing legal and reputational pressure on the company. No specific defect description or recall scope has been released yet, but the scale of the fleet under review creates a new compliance workload. The development arrives while the stock trades lower on the day. Tesla will need to allocate engineering and legal resources to respond while production and software programs continue. Manufacturing pressure is also visible at the Texas plant, where a supplier dispute has slowed Cybertruck output. A supplier is reportedly withholding tooling and demanding daily payments before releasing parts needed for Cybertruck assembly. The dispute has slowed production at the Texas factory and forced Tesla to seek alternative sourcing or legal remedies. The situation highlights supply chain leverage points that remain outside Tesla's direct control, even after vertical integration efforts. Production targets for the vehicle face renewed pressure until the conflict resolves. Tesla is simultaneously investing ahead of production with new Optimus thermal engineering roles. Tesla is actively recruiting thermal design and validation engineers in Palo Alto to address heat buildup in Optimus actuators and power electronics. Human-sized limbs leave almost no room for conventional heat sinks, while continuous dynamic loads from walking and lifting generate non-stop heat. Standard air cooling falls short, pushing the team toward vapor chambers, two-phase cooling, and advanced interface materials, with dyno testing required to validate custom joint actuators under extreme duty cycles. Quiet active cooling fans are mandatory for home and workplace use. The effort targets one of the core physical limits on robot runtime and performance. On the energy side of the business, Tesla is locking in long-term renewable supply instead of hardware constraints. Concord New Energy signed 3 long-term power purchase agreements to supply electricity to Tesla operations in the United States. The deals add renewable generation capacity that supports both vehicle manufacturing and energy storage deployments. Tesla Energy continues to secure dedicated supply contracts that reduce exposure to grid price volatility. The agreements expand the non-automotive revenue base tied to utility-scale projects. Tesla entered a long-term agreement to purchase 1 terawatt-hour of renewable electricity annually from Contour Global's U.S. project. The contract supports manufacturing operations and aligns with broader energy procurement goals. Securing dedicated renewable supply at this scale reduces reliance on spot market pricing for large industrial loads. The deal adds another data point on how Tesla's energy needs now intersect directly with utility-scale generation. Tesla began offering Grok AI access to Indian users and opened test drives for the Model Y Premium rear-wheel drive variant. The moves expand both software features and vehicle availability in a new market. Local customers can now experience the updated infotainment integration alongside the refreshed powertrain option. The rollout follows earlier regulatory approvals for vehicle sales in the country. Tesla opened customer test drives for the Model Y premium rear-wheel drive in India following earlier regulatory clearances. The variant offers a lower entry price point than the all-wheel drive versions already on sale. Local interest centers on range, charging access, and software features in a market with growing EV incentives. The test drive program provides direct feedback on how the vehicle performs in Indian traffic and climate conditions. Tesla has met an additional performance milestone tied to Elon Musk's compensation plan. The package requires sustained market capitalization and operational targets across multiple years. Reaching this particular goal narrows the remaining hurdles but still leaves several others outstanding. Shareholders approved the structure years ago, and each verified milestone reduces uncertainty around the final payout. The compensation structure remains one of the largest equity awards in public company history. Updated FSD safety data from 5 EU countries shows the system operating 5.2 times safer than manual driving across 65 million kilometers. The figures cover supervised operation on public roads in multiple regulatory environments. U.S. drivers can use the European dataset as an additional benchmark while awaiting domestic, unsupervised approval. The release provides a concrete safety multiple that regulators on both sides of the Atlantic can reference. A recent video test compared reaction times across V14 Lite, V12.6.4, and V14.3 on the same scenarios. The comparison isolates measurable differences in how quickly each version responds to sudden obstacles or changing road conditions. The results provide a concrete data point on iteration speed within the current supervised stack. Tesla states that FSD V14 Lite improves proactive and reactive responsiveness. Now, one thing worth watching is how Tesla manages the new suspension inquiry. Regulators opened a new probe covering 1.2 million vehicles for potential suspension defects, adding compliance and legal exposure at a time when the stock is already under pressure. The investigation expands the list of active regulatory matters without yet specifying defect details or recall scope. How the company manages the inquiry will determine whether it stays contained or triggers broader scrutiny. Fleet-level sensor fusion changes the unit economics of perception in a way single-vehicle systems cannot match. When one car's visual map pose and raw GNSS measurements travel to a server and return corrected by relative vectors from nearby vehicles, the cost of accuracy spreads across the entire local fleet instead of remaining locked inside each machine. That shift matters because urban GNSS errors are not random noise but repeatable geometry created by the same buildings and atmospheric conditions every day. A network that measures those errors collectively reduces the per-car compute and sensor burden required to stay inside a lane at highway speed. The practical consequence appears first in dense corridors where individual fixes fail most often. A vehicle entering an intersection can inherit a sharper pose from cars already crossing it, even without direct camera overlap. This matters for FSD because regulatory approval for unsupervised operation will likely hinge on demonstrated performance under the worst local conditions rather than average conditions across a continent. The fleet approach supplies exactly that local calibration at marginal extra cost once the server and map infrastructure exist. For the business, the same architecture lowers the hardware specification needed inside each new vehicle. If relative positioning from the group can compensate for some individual sensor drift, the company can delay or reduce the scope of next-generation onboard compute while still meeting safety targets. That option directly affects capital intensity and gross margin on the vehicle side, an outcome that matters more than any single software release when production volumes scale. The open question is how quickly regulators accept fleet-derived corrections as equivalent to independent sensing when liability questions arise. Before we go, the Optimus thermal engineering push will show whether vapor chamber solutions can keep pace with continuous walking loads in the coming months. That's your Tesla news for today. TSLA closed at $306.90, down $1.95, 0.6%. If you found this useful, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. You can also find us on X at Tesla Shorts Time. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Fascinating Frontiers, the most fascinating news from space and science. Find every show free at naranetwork.com. The age of AI puts real builders on the phone with an AI host. Apply at naranetwork.com, Age of AI apply. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.